Hello and welcome to Ellipses. So, definition: an ellipse is the set of all points whose distances from 2 points called foci add up to the constant d. So essentially, if we have 2 points, which are foci, then you can imagine a string that is attached to the 2 foci. And the string has length d. I'll pull that string taut so it makes a corner. The distance from the point to the 2 foci, if we call those distances d1 and d2, d1 plus d2 adds up to our constant d. Right? So if we find all of these points that have this total distance equal to d, we wind up getting essentially an oval. And so we could see another point that has that same total distance. For some additional vocabulary, if we look from the center of the ellipse and then go out to the edge, going straight through one of the foci, this is referred to as the major axis. Or, yeah, this is on the major axis. You can think of it as a major radius, essentially. And then perpendicular to that, coming out from the center, is the minor axis. So the major axis is the line that runs from the center through the foci. So the major axis runs through both the center and the foci. A minor axis is perpendicular to the major axis. The general equation, again, let's for now assume that the center is at 0, 0. So for now, let's assume the center is at 0, 0. At the origin. And the foci are at C0 and negative C0, or negative C0 and C0. So the foci fall on the x-axis. They can also fall on the y-axis. Furthermore, let's assume the constant total distance is d. Right? Then essentially we have for any point xy on the ellipse, if d1 is the distance, let's shift these. If d1 is the distance between our point xy and the focus negative C0, and d2 is the distance between xy and positive C0, then d1 plus d2 has to equal our constant d. So note that d1 would be the square root of x minus negative c squared, otherwise known as x plus c squared, plus y minus 0 squared, otherwise known as y squared. d2 would be the square root of x minus c squared plus y squared. So what we have then is we have the square root of x plus c squared plus y squared, plus the square root of x minus c squared plus y squared is equal to d. I'm not going to run through all the steps here. You could square and then square again, and you would get to, or square and then isolate the remaining square root and square again, and you could solve. But solving this, or simplifying, this becomes x squared over d over 2 squared plus y squared over d over 2 squared minus c squared, all equal to 1. Typically, before we do that, if we then shift the center, so if we translate the ellipse, to have center HK. Okay. Then we get translating from 0 to h for our x coordinate, we just replace x with x minus h. So we have x minus h squared over d over 2 squared plus y over y minus k squared. Again, translating up to k, we would replace y with a y minus k. And then all over d over 2 squared minus c squared. This is equal to 1. For standard form, we replace d over 2 where we set with a and or d over 2 squared with a squared and d over 2 squared minus c squared with b squared. So we are looking at, therefore, x minus h squared over a squared plus y minus k squared over b squared is equal to 1. I may give myself just a little more room. Turns out that A is the horizontal radius. Okay. B is the vertical radius. And because swapping x and y essentially gives us the exact same formula, we can just stick with this formula. So this formula, so this general formula works no matter which is the major axis. Whichever is the larger denominator will indicate the major axis. So if A is larger than B, then we have that the horizontal is the major axis. So the major axis is parallel to the x-axis. If B is greater than A, then the major axis is parallel to the y-axis. Just a side note, if A equals B, then we have a circle. Furthermore, Since our b squared was d over 2 squared minus c squared, we wind up getting that c squared is just the difference, the absolute value of the difference of the squareds. So furthermore, our c squared is the absolute value of a squared minus b squared, whichever one is bigger out front, but we don't need to worry about that with absolute value. And so we wind up getting, and then our foci would fall out either, depending on sort of, so if we have a horizontal major axis, then the foci fall at h minus c, okay, and h plus c, okay. If we have a vertical major axis, then the foci fall at h comma k minus c and h comma k plus. Right. So if we are originally given a formula in standard form, then we can immediately determine major axis, and we can also figure out what our foci should be. I should note at the beginning of here, when I defined or mentioned the major axis and minor axis, just a note, the sort of radius is always larger on the major axis. So the major axis falls along the longest radius. Again, radius is not really the appropriate term, since it's not a circle, but same idea, from the center to the edge. All right. So from here, we get a measure of something called eccentricity. So the eccentricity of an ellipse is defined as A over, sorry, not A. Let's do the max of A and B, whichever one is larger, over C. So essentially it's that major axis length divided by how far away the foci is. Or how far out the foci is from the center. So it's essentially the major radius over C, right? How far away the foci are from the center. I apologize, I put my fraction upside down. It should have been C over A. I was thinking that it would not make sense for a circle if we had A over C. So C over A is the distance from the center to the foci, or to a focus, over the length of the major radius or axis. So note that if C equals 0, that's a circle. So in a circle, C equals 0. So a circle has 0 eccentricity. The more stretched out the ellipse gets, the higher the eccentricity. And then the eccentricity should never actually pass 1, since the foci fall within the ellipse, so they should be no further from the center than the length of that major radius. So for an example, let's consider the ellipse, which is x minus 5 squared over 16 plus y plus 2 squared over 25, all is equal to 1. Our job is to identify the center, the major and minor axis, the eccentricity, and the foci, and then graph the ellipse. So in this particular case, we have an x minus 5 squared over 4 squared. Plus, I'm going to rewrite this as y minus negative 2 squared over 5 squared is equal to 1. So our center is given by what is being subtracted off. So our center would be 5, negative 2. Right? Standard form is x minus h and y minus k. So that 5 is acting like our h, negative 2 is acting as our k. We have the major radius, or the major axis, should be vertical. Uh, 5 is bigger than 4. Right? So the one along y would be our major axis. The radius, the major radius, essentially is 5. The minor axis or minor radius would be the 4. We have c squared would be 5 squared minus 4 squared. or c squared is equal to 25 minus 16 is 9. So we get that our c is 3. So this is for our foci and eccentricity. So we have our c. We know we are on major axis, so we should have our foci in this case. The major axis is vertical, so they should be h comma k minus c and h comma k plus c, since we know we have a vertical axis, major axis. Our h was 5, our k was -2. So we are looking at 5 comma -2 minus 3 and 5 comma -2 plus 3, otherwise known as 5 comma -5 and 5 comma 1. Our eccentricity is c over our major radius. So we are looking at 3/5 is our eccentricity. So it has a reasonable eccentricity, or a noticeable eccentricity. So when we go to graph this, start with the center, which we know is at 5 -2. Right, so we put our center at 5 -2. We know our foci at 5 -5 and 5 1. We know that our major axis is that vertical axis, has length 5. So going from the center out should have length 5. So the top of our ellipse should be at 5 3. The bottom of our ellipse should be at 5 -7. We know that we have minor axis 4. So we go 4 to each side. Our furthest left point is at 1 -2. Furthest right would be at 9 -2. And then we draw our ellipse from there. So it doesn't have to be perfect. But we get our ellipse. So again, it's not too bad actually graphing. You don't need to know where the foci are in order to graph. You can get a pretty good sketch just from knowing the center and the major and minor radius and which direction the major axis is in. So that is ellipses. And the next video, we will look at our last particular conic section of hyperbolas.